A biased four-sided die has faces marked 1, 3, 5, 7. The random variable x represents the score on the die when it is rolled. The cumulative distribution x of the function fx is the cumulative distribution, is given below. Now always remember, we need the probability distribution table to do the sums. This is not a probability distribution table. This is a cumulative distribution table. So what a cumulative distribution means is that if you have probability of f2, it means x is less than or equals to 2. That means add up all the probability up to 2. So you just add it up. So f2 means that. So here, if you have a cumulative function looking at the table 1, it means all the probability up to 1. Since there is nothing else, so f1 would be probability of 1. So let's try to draw the table. Question number A. So we need 1, 3, 5, 7 because x is the random variable where it has the number on the die. It has a four-faced tetrahedral die. So we have probability of x equals to x. So the first one, since cumulative is total, so f1 means all the probability added together, which is the same as p1. So this is going to be 0.2. The next one is f3. F3 means all the probability added together. That means p1 plus p3. That's what it means because there are only two up to that point. So now we already know what p1 is. So if we cancel from f1, if we remove from f3, if we remove f1, we get the probability 0.5 minus 0.2, which is 0.3. So that would be the probability of p3. Remember, f3 is the total of all the probability up to that point. So if we remove from this the previous probability, we get 0.3, and that is p3. The next is f5. F5 means add up all the probability up to that point. That means previously we had p1, then p3, then p5. So from here, if we remove everything, so if we consider f3, which is p1 plus p3, all the two probabilities up to that point. So if we subtract f3 from f5, so this thing and this thing will cancel, this thing and this thing will cancel, we will only have p5. So we have to subtract it. So 0.9 minus 0.5, it turns out to be 0.4. So this is 0.4. And finally, once you add up all the probabilities, you get a total of 1. So for finding p7, we have to subtract from 1 the previous probability, which would be 0.1. So let's check whether the total probability is 1. So 0.2 plus 0.3 is 0.5, plus 0.4 is 0.9, plus 0.1 is 1. So the total probability is 1. It works. So remember, in case of cumulative probability, all you have to do for finding PA, you have to take FA and from that subtract the previous one. That's the logic behind cumulative function and basic probability function. The next one, question number B, is add up the probability greater than 2, less than or equal to 6. So what we do over here, greater than 2, less than or equal to 6. So what is greater than 2? So greater than 2 is 3. So probability of 3. Then less than or equal to 6. Since there is no 6 over here, less than or equal to 6 has to be 5. So we just add up 3 and 5 together, which is 0.5 plus. Now be very careful. This is not the probability function. The probability function is this one. We cannot add this one because this is the total function. So we have to take a 0.3 for probability of 3 and 0.4 for probability of 5. It turns out to be 0.7. Now question number C. Question number C is write down the value of f4. Now to find the value of f4 is to remember f4 means probability of x is less than or equal to 4. All the probability up to f4. So less than or equals to 4 is going to be probability of 1 plus probability of 3. Remember, these two are less than or equals to 4. So it turns out to be, so probability of 1 is 0.2 plus probability of 3 is 0.3, which is 0.5. Now this sum is quite interesting. it is a normal distribution sum, but it is not the normal distribution type 2 sum where you have to find the mean or standard deviation. That's not the thing. Usually when the mean and standard deviation is unknown, we have to find them. But here all we have to do is find probability. Now, in order to find the probability, the only way to do this is to draw the picture. Otherwise, it would not be possible. So let's start with this. First of all, the information that we have is that we have a normal distribution where the mean and variance is unknown, and we have a probability given that y is less than 17 is equals to 0.6. We have to find the probability y is greater than 17, and that would by itself be 1 mark. So it should not be something we go through the z-score and everything. It should be very simple. So let's do this by drawing the picture. The picture would be, this is not the standard normal distribution bell curve. This is mean. If you remember, this is mean, and we have 17. Obviously, if we start shading, less than 60%, less than 17 is 60%. So we start shading over here. That's shading. So this is 50%. So 60% should be around here. So this is 17. So this is 60%. So if you think about something greater than, so greater than 17, it should be 40%. So it is 1 mark. We shouldn't worry about the steps or anything. So we can write this is equals to 40% directly, or 0.4. No steps required. In question number B, what we have to do, we have to find the probability between mu and 17. Now take a look over here. We can use the same picture from before. Think of, this is the y, this is y. This is not the standard normal distribution, that is not needed. So this is mean. So we already know from before that up to 17, it is, greater than 17, this portion, if we consider this portion, we know from before that is 40%. Now, one thing we know is half of the bell curve is 50%. So this is 50%. So this half is also 50%. But from the 50%, if this is also already 40%, then this portion should be 10%. So from mean to 17, this portion should be 10% directly, without any steps or anything. We can write it is 10%. Now the final one, question number C. Question number C is a conditional probability where we divide. That's what we do. So we have a probability of y is less than mean. Conditional, we have a probability y is less than 17. So that's what it is. Now question number C is this information, this means given. It means the probability that we do for basic probability when one probability is divided by the other. That's what it means. So if you consider this probability, so what's going to happen is we can think of this division, this one divided by this one. So y, probability of y is less than 17. We already know that is given. Less than 17 is 0.6. So this is 0.6. And probability of y is less than the mean. We know mean less than the mean is this portion, and that is 50%, and that would be 0.5. So the probability would be 5 by 6. Question number 5 is a straightforward probability distribution sum. And the first thing that we have is the expected value is given. It is 0.8. So one thing we know is that a plus b plus a plus c equals to 1. That means the total probability is 1. And we can write it as twice a plus b plus c equals to 1. This is one of the information. And we also know that the expected value is 8. So we can write expected value rule. As you know, expected value is random variables. So minus 2 into probability plus 0 into probability plus 2 into probability plus 4 into probability, and this is the expected value. So we can calculate this. So minus twice a plus 0 plus twice a plus 4c. So this thing and this thing cancels off, and we know the expected value is 0.8. So when we divide expected value with this, this is 4c, so divided by 4, that would be 0.8 divided by 4 equals to c, therefore c equals to 2.2. So that's the value of c. Now for question number B, we know ex squared equals to 5. So let's use the formula for ex squared. Ex squared is random variable square into probability plus random variable square into probability plus random variable square into probability plus random variable square, and we know the value of c. The value of c is 0.2. So ex squared is 5. So we can write 4a and plus 0 plus 4a plus 4 square is 16 into 0.2. So that turns out to be 4a plus 4a is 8a plus 16 into 0.2 is going to be 3.2. Therefore 8a, we can send this to the other side, 5 minus 3.2, and that is going to be 1.8. Therefore a equals to 1.8 by 8, that is 0.225. 0.225, and we can find the value of b from the total probability. We can write 0.225, that is a, plus b plus 0.225, that is a, plus c is 0.2 equals to 1, and that turns out to be 0.225 plus 0.225 plus 0.2 plus 0.225 plus 0.2, and that is 0.65. We can write 1 minus 0.65 is 0.35. So restate the answer. A equals to 0.225 and B equals to 0.35. Question number C is variance. As we know, the formula for variance is ex squared minus mean squared. So ex squared is given 5, we know, and mean is 0.8, so minus 0.8 squared, and this would be 5 minus 0.8 squared, 4.36. Now question number D, E deals with coding. So we know y equals to 5 minus thrice x. So D would be, so expected value of y is the same as, instead of y we can write down the value of y, 5 minus thrice x, and using the coding we can write 5 minus thrice expected value. So this is 5 minus thrice into expected value is 0.8, which is already given, and that would turn out to be 5 minus 3 into 0.8, and that is 2.6. And in question number E, variance of y would be the same as 5 minus thrice x, and you know in variance the constant is not considered. All we take is the coefficient of x, so that would be minus 3 squared into variance of x. Minus 3 is 9, and variance of x is 4.36, so that would be 9 times 4.36, which is 39.24. In question number F, we have y is greater than 0. Now we can do this sum by solving the inequality. So probability of y is greater than 0 is the same as 5 minus thrice x is greater than or equal to 0. So we can write minus thrice x is greater than or equal to, send the 5 to the other side, it becomes minus 5. So we can write probability of x is, now if you send the minus 3 to the other side, it becomes by inequality less than or equals to minus 5 by minus 3, which becomes probability of x is less than or equals to 5 by 3 is 1.67, something like that. Now in order to find the probability of x is less than or equal to 1.67, we have to look up the probability distribution table. So less than 1.67 is going to be 0 and minus 2, these two probabilities, which is a plus b. So if we add it up, so this is equals to probability of a plus b, and we already know the probability of a is 0.225 and the probability of b is 0.35, and if we add it up, 0.225 plus 0.35, we get 0.575.